All right, guys, so again, graphing parabolas is very important in Algebra 1 and especially in Algebra 2, and understanding all the details about the parabolas, right? So we're going to be doing this two-sided worksheet. On this video that I'm recording right here, I'm going to be explaining the odd ones. On the next video, I'll explain the even ones. But the idea is, with you guys, I'll do about half of them, and then you guys could take the other half of class to do the other half of the front side. And then tomorrow with the substitute, you should be able to do the back side on your own. So let's take a look at number 1 right here. And the very first step to graphing a parabola is to find the vertex. So let's all do this together. Write down the parenthesis. And in order to find the vertex on the wall right there, it says that you need to use the vertex formula, x equals negative b over 2 times a. And of course, you use parentheses when you plug in. So the b value is what? When you look at that number 1 equation.
-3.
Okay, remember that the x squared has the a.
0.
The b is with the x, and the c is the number all by itself without a variable. You guys remember that? No? Okay, check this out. Let me write down a standard form quadratic trinomial equation right here. Y equals ax squared bx c. Right? That's your standard form quadratic trinomial equation. What's the a value? The a value is in front of the x squared. So what's the a value here? 1. All right, so let me just label it. A is right there. It's 1. How about the b value? See, the b value is with x. Is there an x right here in the middle? No, there isn't. So what's the b value? There is none. So what number represents nothing? 0. So the b value is 0. So I would just squeeze it in right there. The c value is -3, but there is no c in the formula. So let's plug in the b value of 0 and the a value of 1. And we could work this out. -0 divided by 2, that's just going to be 0, right? So what did we just find? We found the x value of our vertex. The x value of our vertex is 0. We still need the y value, and that's really easy to do, right? Because when you plug in x into a standard form quadratic, your output will be your c value. Again, if you plug in 0 right in there, 0 squared 0, 0 minus 3 is the c value, -3. Okay, so when I plug in 0 for x, I get out a -3 for y. That is my most important point. Let's graph that most important point. 0 on the x, -3 on the y. Here it is. Put a big fat dot right there. And what's step 2 on graphing parabolas? Your axis of symmetry. Right there it says step 2, draw your axis of symmetry, which is a vertical line going right through that vertex. It's kind of unnecessary here because the axis of symmetry happens to be the y-axis. But they will ask you to find the equation of this green vertical line. And the equation of any vertical line is x equals, and you just have to state the x value of where this line is at, which is really the x value of your vertex. So the x value of your vertex is 0. So that's the equation of the axis of symmetry. By the way, guys, in addition to graphing it perfectly, we need to go to this thing, additional details paper, and start filling it in, right? So we said that the vertex was 0, -3. And then on step 2, we drew the axis of symmetry, and we said it was the equation x equals 0, right? And of course, we're going to be filling this in as we go. Let's first finish graphing it, okay? So I have the vertex. I know that it opens. How does it open? Does it open up or down? Up, because the a value is positive. So I know it's opening up, but I do want precise coordinates. So how could I find more coordinates? That's step 3 up here. XY table, input, output table. All right, so I could plug in some values. Which numbers would be good?
1, 2, and 3.
1, 2, and 3. Okay, that's fine. And that's perfect because 1, 2, and 3 are all on the right side of this axis of symmetry of the vertex. So you do want to plug in numbers that are on the same side. Like you don't want to plug in 1 and -1 because it's going to be the same answer reflected, right? So why do twice as much work? Why not just pick values that are on the same side? That way you could map them over to the other side with the reflection line called the axis of symmetry. All right, so let's plug in 1, 2, and 3. 1, if I plug in 1, and we could do this in our heads here, I would use a calculator when you're taking the quiz or test on your own. 1 squared is 1. 1 take away 3 is -2, correct? So let's go to the coordinate 1, -2, which is right here. What if I plugged in 2? What's 2 squared? 4. And what's 4 take away 3? 1. What if I plugged in 3? What's 3 squared? 9. What's 9 take away 3? 6. So if I go to the coordinate 3, 6, actually let's go to the coordinate 2, 1 first. I forgot about that guy. 2, 1. 2 on the x, 1 on the y. There it is. If I go 3, 6, 1, 2, 3, 1, 2, 3, 4, 5, 6. I'm going to be 1 unit off the graph. I'll put it there anyway. It's a good reference point for when I draw my arrow. And let's map over all the coordinates. So this 1 unit dot from the axis of symmetry, I go 1 unit this way and place my dot right there. Same thing with this guy and the one that's off the graph up here. So again, 1 unit, 1 unit. 2 units, 2 units. 1, 2, 3 units, 1, 2, 3 units. Draw your parabola, and you don't have to go all the way off the graph. And I put those coordinates out there so I could point at them. Because some people like go like this, point that way. That's wrong, right? You got to actually point at that following point that's outside of the graph. All right, so we have our perfect graph. That's great. But we need to fill in the rest of the information with regards to this parabola. So how about the domain? Do we know the domain of this parabola? Domain are the x values, all real numbers. Any domain of any parabola, doesn't matter if it's opening up, if it's opening down, if it's wide, if it's narrow, all domain answers for parabolas are simply x equals, you could write out all real numbers, or you could do the r with the 2 sticks. X equals all real numbers. Now the range are your y values. Let me give you a visual of the domain first. Okay, the domain's saying that the parabola does go to the left forever. Even though it goes up, it continues to go this way, and it continues to go that way. That's the domain, the x values. The range are your y values, and this parabola is clearly above a certain value. It's not, the parabola doesn't exist down here. It only exists from this point up. So if it's opening up, I know that it's going to be y is greater than or equal to, and greater than or equal to what? To the y value of your vertex. What's that y value of your vertex? What is this level right here? What's this level? -3. That's the y value of your vertex. So y is greater than or equal to -3. What else do they ask us for? 1e, right here, it says, what's the y-intercept? Well, the y-intercept is where your parabola crosses the y-axis. This is the location, right? What's that location? 0, -1, 2, 3. 0, -3. Now, here's another easier way of finding the y-intercept. We should all know that to find the y-intercept, we have to set x equal to 0. You guys remember that from semester 1, right? To find the y-intercept, you set x equal to 0. To find the x-intercept, you set y equal to 0. So anyways, to find the y-intercept, we're going to set x equal to 0. And you could just think of it, when you set x equal to 0, it's always going to be your c value. So if I just remember this, if I want to find my y-intercept, I need to set x equal to 0, which means my coordinate, my x value of my coordinate, I'm going to set that equal to 0. And if I did set it equal to 0, the c value -3, will be my output. So 0, -3 is my y-intercept value. Okay? Yeah. Good question. If you just put y-intercept is -3, that's perfectly fine. Right? So if for some reason you just put the y-intercept is -3 and you left it like that, that's perfectly fine. Because I already know that you're talking about that it's going to cross, it's going to cross the y-axis right here at -3. Okay? Now check this next one out. We haven't really talked about these guys. The x-intercepts, right? You could find the x-intercepts algebraically, and we will do that in future sections of this class. But right now, let's just look at the graph and give an estimate, all right? An estimate, just to give me a rough idea of where the parabola crosses the x-axis. So like, where do you think the x-axis, where do you think the parabola crosses the x-axis? Obviously, right here and right there. So what would you say that this location is? Is it -1? Is it -2? Or is it between the two? Between the two. Now give me an approximation with the decimal. -1.8, 1.9, right? Whatever, any of that is fine, okay? So for my x-intercepts, I'm going to put -1.8. Oh yeah, you know what? Let's do this better. Because this is an approximation, let's do the little squiggly equal sign. Because it's not precise, all right? We're just approximating here. We're going to say -1.8 or -1.9. And then what else? Is there another one? Yes, it crosses over here as well. What would that be?
1.8.
Positive 1.8, right? Roughly, all right? So we could say -1.8 and positive 1.8 or comma positive 1.8. These are just approximations, okay? Now, don't think, oh, if one's -1.8, the other one has to be positive 1.8. Sometimes it'll cross like at -3 and at +1. It depends where your vertex is at. Right here, the vertex happened to be on the y-axis. That's why it ended up being perfectly the same, but it's not always the case. All right, we have number 1 done. Let's jump to number 3, since we're doing the odd ones on this one. All right, let's do number 3 here. First thing to do is what? Vertex. That's right, vertex. And we're going to use the formula x equals -b over 2 times a. And of course the a value is what? 1. The b value is what? -4. The c value is what? 0. You don't need the c value anyway. Okay, so the b value is -4. Put that -4 right in the parenthesis. The a value is 1. We end up with a -4, which is really a +4 plus. So you have a +4 divided by 2. What is 4 divided by 2? 2. So our vertex x value is 2. We still need the y value. How do I find the y value if I already have my x value? Plug it in. So right here I'm going to put a 2, and right there I'm going to put a 2. All right. You could show your work if you want. Parentheses squared -4 times parentheses, and we said we're plugging in a 2 right in there. So what's 2 squared? 4. And what's 4 times 2? 8. And what's 4 take away 8? -4. So when I plug in 2, I get out a -4. So the vertex is at 2, -4. That's the most important point there is. Let's go to 2, -4. 2 on the x, -4 on the y. We are way down here. What's my next step? Axis of symmetry. Draw it first. Might as well give the exact equation of that axis of symmetry. What is it? It's a vertical line. It's not y equals, it's what? X equals... Where? Let me ask you this. We know it's x equals... Does it cross the x-axis at -3? No. Does it cross at -1? It crosses at 2. So the equation has to be x equals 2. X equals 2. That's your equation for the axis of symmetry. If you got a graphing calculator and you typed in x equals 2 and then hit the graph button, it'll graph this vertical line right through the x value of 2. Anyway, we have the vertex, we have the axis of symmetry. Let's get some more points here. Going for an xy table, just like we did before. I could plug in values for x and pull out values for y, right? That's what I did on number 1. But you know what? Since the a value is 1, I'm going to use the pattern. Remember the pattern? It's 1, 1, 2, 4, 3, 9. You don't have to use a pattern if you don't want to. You could plug in numbers for x, pull out numbers for y. Okay, how about this? If I wanted to plug in numbers, what would be 2 good numbers to plug in? 0 is good, and what else? 1. And 1. So plug in 1 and plug in 0. If you plug in 1, it'll give you a coordinate somewhere right here. If you plug in 0, which is right here, it'll give you a coordinate somewhere up here. That way you could have your parabola and map it over to the other side. Okay, so let's plug in 1. Let's do this in our head. X, what's 1 squared?
1.
And what's 4 times 1? 4. And what's 1 take away 4? -3. So when I plug in 1, I get out a -3. Let's do that. 1 on the x, -3 on the y. Here I am. Let's plug in 0. 0 is easy to plug in. It's just going to be your c value, right? What's your c value? 0. There's nothing there. Yeah, so when you plug in 0 there, plug in 0 there, there is no c value. Everything becomes 0. So when I plug in 0, I get out of 0. So let's plot that point, 0, 0. It's right there. All we have to do now is map it over to the other side. 1 dot there, 1 dot there, and we have a very good description of our parabola. Now, I do want to mention this, guys. It's not really necessary to use an XY table when your A value is 1, because you can use the pattern 1, 1, 2, 4, 3, 9. 1, 1, 2, 4, 3, 9. From the vertex, you could have gone 1 over, 1 up, and you'd get to that green dot. You could have gone 2 over, 4 up, and gotten to that green dot. You could have gone 3 over, and then 1, 2, 3, 4, 5, 6, 7, 8, 9 up here right on the edge, and you'd actually get to this dot up here. And you could map that dot over to over here, and you could even have a bigger parabola or further out parabola, right? So you could use a pattern if you want, or you could just stick with the XY table if you don't want to mess with the pattern. Let's answer all the extra details about question 3 here. Okay, so let me see. The vertex was 2, negative 4. The axis of symmetry, that vertical green line, it's always x equals, and it's 2 in this case. The domain, what's the domain? X equals all real numbers. You need to have the x equals though, right? Don't just say all real numbers. And the range, y is it going to be greater than or equal to, or less than or equal to? Does it open up or does it open down? That's the question. It opens up, so what do you have? It has to be greater than or equal to, right? If the parabola is opening up, it has to be greater than or equal to, right? So greater than or equal to the y value of your vertex, which, yes, is negative 4. Perfect. Okay. The y-intercept. Oh, we could clearly see the y-intercept is what? Remember, y-intercept is where your graph crosses the y-axis. So you could just say 0, right? Or you could give the coordinate, plug in 0, you're going to get out of 0. Or you could just say 0, whatever you want, right? The y-intercept is 0, crosses the y-axis at 0. Now, how about the x's? Where does it cross the x-axis, the x-intercepts? 4 and 0, right? Here's your x-axis. The parabola crosses here and here. It crosses at those two locations, x equals 0 and x equals 4. So you could give coordinates if you want. You could say 0, 0 and 4, 0. Or you could just say the x-intercept is 0 and 4. It's totally up to you. I'm just going to say 0 and 4 because it crosses at the x value of 0 and at the x-axis at 4. And that's about it for number 3. Dang, this video is getting long. It's okay. Let's go to number 5. 5 has an A value that's not 1, so we can't use the pattern 1, 1, 2, 4, 3, 9. Let's jump right into it. Let's find the vertex. Using the formula, x equals negative b over 2 times a. And the b value is negative 4. The a value is positive 2. So you have a negative 4 for b. That's really tiny, sorry. Negative 4 for b and negative 2 for a. So up on top I have a negative 4, which changes to a positive 4. And I have on the bottom a negative 4 because 2 times negative 2 is negative 4. So 4 divided by negative 4 is negative 1, and that is my x value of my vertex. I still need my y value. I need to plug that in. So I am going to show my work on this one. I'm not going to show my work. I'm just going to show you what to do if you're doing it on your piece of paper. Plug in the negative 1 with parentheses right in there. Now let's do this work in our head here. What's negative 1 in parentheses squared? That's positive 1, right? And then what's positive 1 times negative 2? That's negative 2. Does that make sense? So this is negative 2. And over here, negative 4 times negative 1 is positive 4. So you have a negative 2 plus 4. What's negative 2 plus 4? That's 2. And what's 2 plus 3? 5. So when I plug in a negative 1, I get out a 5. Of course, all this work could be done perfectly with your calculator, right? I don't recommend doing it in your head the way I just did right now. So that's our vertex. Let's graph the most important point. Negative 1 on the x, 5 on the y, which is up here right on the edge, almost off the graph. Second step is to draw your axis of symmetry. Could somebody give me the equation of this axis of symmetry, since we have to give the equation anyway? What's the equation? X equals negative 1. That's right. Perfect. That's the equation of the axis of symmetry. Let's get more points. So I need an XY table. Let's find some more coordinates. What numbers would be good to plug in? You want to plug in two easy numbers that are on the same side, 0 and 1. Perfect. 0 and 1. 0's here, 1's here. They're both on the right side of this guy. That's what we want. We want two values that are on the same side. So let's plug in 0, which is easy to do. And not only that plugging in 0 gives us the y-intercept value. So if we plug in 0, it's going to be your c value as your answer, right? 0 squared, 4 times 0, 2 times 0, 0 take away 0, plus 3 at the end. You're going to end up with the 0, 3. The c value is always your output when your 0 is your input on a standard form quadratic equation. Anyway, let's plug in a 1, and this requires a little more thought. 1 squared is 1. Negative 2 times 1 is negative 2. 4 times 1 is 4. Negative 2 minus 4 is negative 6. And negative 6 plus 3 is negative 3. Again, do it on a calculator. So 0, 3 is right here. And 1, negative 3 is down here. Let's map those blue dots over to the other side. I want to put them as green right here and here. So as you can see, 1 unit away, 1 unit away, 2 units away, 2 units away. I already have my beautiful parabola. It is a little more narrow than usual because the a value is further away from 0. The closer it is to 0, the wider it is. The a value is negative 2 here. That's why it's a little more narrow than the usual a value of 1. So we graphed it. Now let's just go and answer everything we possibly can about number 5. So what do we know here? The vertex is negative 1, 5. The axis of symmetry we said was x equals negative 1. The domain we know is x equals all real numbers. It's always the same answer there. The range is y has to be either greater than a certain value or less than a certain value. And we're talking about the y value of the vertex. So what do you guys say? Is this greater than or equal to or less than or equal to? Less than or equal to. Why is it less than or equal to? Because it's opening down. So it has to be less than the vertex y value. So we're going to put less than or equal to. And yes, the y value of the vertex is 5. Perfect. That y level is at 5, and the whole parabola is at 5 or below 5. All right, how about the y-intercept? Where did it cross the y-axis? It crossed at 3. Perfect. It crossed right here at that location. That's the y value of 3. Now you could just say 3, or if you want, you could give me the coordinate 0, 3. How about the x-intercepts? This is where it gets a little funky. Okay, so you're saying 2 point, somewhere over here? Okay, negative 2 point, I don't know, give me something. It looks pretty much in the middle right there, no? So 2.5, that'd be a good one. I mean, these are just approximations, so again, let's do this. Let's do a little squiggly line so we know that it's not exact. It is negative 2.5. And how about the positive one? Like 0.5, right? 0.5. So those are your two x-intercepts approximately. Where does it cross your x-axis? At about negative 2.5. Where does it cross your y-axis? At about 0.5. I mean, I said y. Both x-intercepts are at negative 2.5 and positive 0.5. Woo! I'm tired. We still have one more to do on this video of the odd ones. Number 7. Maybe I should just let you guys do number 7. Vertex. Coordinate. Formula. Parentheses. A value is 3. B value is negative 6. C value, we don't care. It's not in the formula. B value is negative 6, plug that in. A value is 3, plug that in. Simplify, the negative negative changes to plus plus. I really do have a positive 6 over 2 times 3, which is 6. That's really a 1. So the vertex x value is a nice, beautiful 1. How do I find the y value? I plug it in. So let me rewrite my equation. Y equals 3x squared minus 6x minus 2. Notice that I put parentheses instead of x's. That's because I want to plug in a 1 into the x's. Why? Because x equals 1. Let's do the math. 1 squared is 1. 3 times 1 is 3. 6 times 1 is 6. Let's not forget about the minus sign right there. Bring down the minus 2. We have 3 take away 6, that's negative 3. Take away 2 is negative 5. So your y value is negative 5 on your vertex. That's the most important point. Let's go to the coordinate 1, negative 5, which is way down here, right on the edge. Step 2 is to draw your axis of symmetry, the vertical line going right through that most important point called the vertex. Might as well give me the equation of that axis of symmetry. Okay, you can't just, what's the equation of that vertical line? X equals, what you guys are telling me that this green line crosses the x-axis at negative 5? It crosses at 1, right? Okay, so x equals 1. That's the equation of your axis of symmetry. We need more points, and we can't use the pattern because the a value is 3, which means we can't use the 1, 1, 2, 4, 3, 9. So we actually need to plug in values. Give me an easy point to plug in. 0 is always the easiest. Not only that, it'll give you your y-intercept. That's great. So when I plug in 0, I get my c value as my answer, right? Plug in 0 here, 0 there. The only thing that's going to be left over is the c value, which is negative 2. So let's graph 0, negative 2. That's right here. You could map it to the other side. That's right here. Now, what other number would be good to plug in? You could plug in 1, but we already did plug in 1. That was a vertex. Negative 1 would be good. Then you could map it over. Or negative 2 would be good, but it's probably going to be off the graph. Or how about this? You see, do you guys understand that we plugged in 0 and we got out negative 2? We plugged in 1 and got out negative 5. We plugged in 2 and got out a negative 2. So what other number could you plug in? You could plug in 3 if you want, and then map it over to this side. Does that make sense? So you could either plug in 3 or plug in negative 1. It's totally up to you. What do you guys want, 3 or negative 1? Negative 1? Okay. So if I go 3x squared minus 6x minus 2, and I plug in a negative 1 right in there, what's negative 1 squared? Come on, guys. What's negative 1 squared? That's 1. What's 3 times 1? 3. What's negative 6 times negative 1? 6. What's 3 plus 6? What's 9 take away 2? 7. So we end up with negative 1, 7. And that's way off the graph, so we're not even going to be able to show it, right? If we go negative 1, 3, 4, 5, 6, 7, we're 2 units off the graph. Whatever. I'll plot it up there. 2 units off. Map it over to the other side. There's your parabola. I wouldn't even go that far. I would just draw the arrows pointing toward those dots that are off the graph. Last but not least, let's get our additional paper here. And what's the vertex? What's the vertex? 1, negative 5. 1, negative 5. How about the axis of symmetry? X equals 1. How about the domain? Come on, guys, all real numbers. It's a free point right there. How about the range? Y is what? Greater than or equal to, because it's opening up. And what's the value? Negative 5, the y value of your vertex. How about the y-intercept? Where does it cross the y-axis? At negative 2. Or you could say the coordinate 0, negative 2, right? How about the x-intercept? Where does it cross the x-axis? It's 2 locations. Negative. Now, do you think it's perfectly in the middle? Or it's a little... Negative 0.2. That's good. All right. Again, they are approximations. negative 0.2. And how about in the positives? What would you say? About 2.2, right? Not exactly 2.5, but maybe 2.2. So let's put comma 2.2. And that's it, guys. Wow, half-hour video. Time flies when you have fun. You guys did the odd ones with me. I did the odd ones for you. How about go back and do the even ones?